Hello everyone, let's take a look at our next problem. Integrate 1 over 1 plus sine x. This is not a standard integral in any way. I might just take a random guess at something along the lines of log of 1 plus, this is not going to work. I guess we don't need the absolute value signs here because sine x plus 1 is always non-negative. It can be 0, but we're just testing things out here. So f prime of x is going to be 1 divided by 1 plus sine x times cos x. Yeah, so that doesn't work. What about if I replace sine with an exponential representation? There will be complex numbers involved, and then do some factoring in the denominator. Sine x is equal to e to the ix minus e to the minus ix over 2. So then 1 plus sine x is 1 plus e to the ix minus e to the minus ix over 2. And I want to think about writing this as a difference of squares. Or not a difference of squares, but as what do I mean? Okay, well let's just write this as e to the ix plus 2 minus e to the minus ix. Oh, this isn't going to quite, if this were a plus sign, things might be looking up, but it's not. And I guess technically I'm missing an I here, right? If I top minus bottom, to I sine x, okay, but will this help anything? One over 1 plus sine x. I've never seen this. My instinct would have told me that there's no nice way of doing this. 1 over 1 plus sine x. So maybe this is something that would work. I have 1 over 1 plus sine x plus 1 over 1 minus sine x is equal to 1 over cos squared x. And I think, can this be integrated? This is what? Secant squared x. I'll come back to that. Maybe we can integrate that. But the point is here we have very similar functions. Like this is these functions are reflections of each other, right? This is if I replace x with negative x, this gets replaced with this. So you know, there might be a relation between their antiderivatives. Right, integral from 0 to x, 1 over 1 plus sine t dt, plus the integral from 0 to x, 1 over 1 minus sine t dt is going to be equal to the integral from 0 to x secant squared t dt. Okay, let's keep the first one the same. And here I'm going to replace t with negative t. We get a negative sign here. But now this becomes plus. This is from negative x to 0. And I don't know if this will work because, yeah, these functions aren't. It's not an odd function, though. It's not an odd function. So maybe I need to. What will happen if I subtract here? What happens to this identity? Okay, I get this, which can definitely be integrated. Right, this can definitely be integrated with a substitution. U equals cos x. So if I then, yeah, so this means okay, let's think of it this way. Let's go like this. Let's go like this. I'm going to sort of start some things again here. Okay, so if I add these two lines together, it gives me sort of an identity for 1 over 1 plus sine. This tells me that 1 over 1 plus sine x is equal to 2 secant squared x minus 2 sine x over cos squared x. And if I can integrate both of these individually, then I'll be done. I know I can integrate that. So I just need to think about how to integrate secant squared. There might just be some common substitution that can be done. Well, secant squared, is there an identity I can use actually? That'll give me something with tan squared. And I know there's quite a few weird trig integrals. I'm going to take a random guess here. And see what happens. Okay, so this didn't work. What I have here is the antiderivative of secant, not the antiderivative of secant squared. Well, let's, while my unconscious brain works on that other part, let's just do this integral quickly. This is the integral of 1 over u squared du, negative sign where u is equal to cos x, and so du is equal to negative sine x dx. Okay, so I have 1 over u. That's my antiderivative, so I end up with, just 1 over cosine x. All right, we can check that one. Derivative of this will give you 1 over cosine squared multiplied by negative 1 over cosine squared multiplied by negative sine. So that works. How do I integrate secant squared? I'm not sure. So what we've got so far is this. Maybe there's a factor of 2 missing here. In fact, there might be a factor of 2 missing on the yeah. So at least we have this. At least we have this representation of the integral. I need to think about how to do that. I don't know if there's a well-known integral identity for this. I might just look something up. And if I find something reasonable, that I'll come back here and fill in the details. But if I don't, then I'll just say now, thanks for watching. So I'm an idiot, and the integral of secant squared is just tangent. In fact, I use this in my rough work up above. I use the fact that the derivative of tangent is secant squared at some point. So this should tell us that, you know, the integral of 1 plus sine x is -2 over cos x plus 2 tan x plus c. And I want to check this by taking a derivative. So let's let this be equal to f of x. Then f prime is equal to -2 times 1 over cos squared x. That comes with a negative sign, but then it gets multiplied by negative sine x for the chain rule, plus 2 secant squared x. So I've got 2 secant squared x times 1 minus sine x. So this is 2 times 1 minus sine x divided by cos squared x, which is 2 times 1 minus sine x over 1 minus sine squared x. Think of the bottom as a difference of squares. This gives us 2 over 1 plus sine x. But why do I have an extra factor of 2? These factors of 2 came in when I started working through these identities. I see where it is. It's because I forgot to cancel a factor of 2 here. This is correct, and this is correct. But when I add these two things together, this should have been replaced. There should be a 2 in the numerator here. When I add this line and this line together, there will be a 2 here, which will cancel all the 2's on the right. Yeah. So we're missing, everything is correct here, except for the fact that we don't want a 2 in the numerator. In the couple of minutes break that I took in looking up the antiderivative of secant squared, I also found another representation for this integral, 1 over 1 plus sine x. It can also be written as tan of x over 2 minus pi over 4. I'm not sure exactly where this way of writing it comes from. I suspect it might, if I continued the approach earlier with the complex exponentials, I think maybe that might be one way of possibly getting this. Or maybe if I take the answer here and do some manipulations with things, maybe that might be another way of writing it like this. Anyway, this was a little bit of a roundabout way, but if you want a straightforward derivation of this integral, then see the solution video, which is linked here. Thanks for watching.